Okay, good morning everyone. So in today's lecture we're going to review the complex numbers. They're important for solving linear differential equations of order larger than 1. So just some review, we'll just go over a brief review, and then if we have time left, we'll just define a higher order differential equation. So the idea about complex numbers is you just add this number I, defined by this relation, I squared is -1, to the real numbers. A complex number has the following form. A plus bi, where a and b are real numbers. You can visualize this actually on what's called the complex plane. So on the complex plane, you have the real numbers, and you have what are called imaginary numbers that run perpendicular to the imaginary number. Imaginary number has the form b times I. That is just a constant. So a complex number really just means you're adding a real number to an imaginary number. You can visualize this as a vector. If real numbers are in one real number line, and imaginary numbers are in a perpendicular number line, adding them is equivalent to this vector. We go a units to the right on the real number line, and b units up on the imaginary number line. There's two important things imaginary numbers have, and that is they have magnitude. So they're usually written as z plus bi. Complex numbers are written as real number plus another real number times I. And as you see here, they can be visualized as a vector. So they have magnitude square root of a squared plus b squared. And again, that's just because go a units over to the right, b units up, right? The total length you went is square root of a squared plus b squared by the Pythagorean. And they also have something called argument. So principal argument, that's the angle that this vector makes with the x-axis. So there's a few ways of defining it. One way you could define this as arctangent of b divided by a. So notice arctangent actually, that would be appropriate for arctangent ranges from -pi over 2 pi over 2 So that would be appropriate for complex numbers that live in either the first or the fourth quadrant. Or I guess, but it obviously is also possible for, I'm sorry, this would range from so this would range from minus pi to 2 if so again that's appropriate if we're in the first or second quadrant. Fourth quadrant, if we're in the second or third quadrants, then we would probably have to define this as being something like cosine of A divided by epsilon. The main point here is it's just the angle. Whether or not you want to use this number depends upon quadrant or cosine range between 0 and up to pi. So first, second, and then maybe we have to use, say, something like arc sine or arc sine plus phi if it was. But the main point is this is the angle. It's the angle Z makes with the limit. So whether or not it's the arc cosine, arc sine, or tangents, depending on context, we'll go over that a little. That's not going to be super important in this class. What's more important is knowing how to add complex numbers, subtract complex numbers, multiply complex numbers, and divide complex numbers. And then there's a few formulas also we're going to need to know. And they're just going to be important because sometimes what comes up in the, sometimes